Ichito, I can't hear anything.
Can you hear me now?
Now I can hear you. Yep.
Yes. Okay. Good to go. Now we can hear. Okay. Good morning, everyone. As we all know, today we are going to conduct a virtual talk on a database management system for second year students of BCA of Bapuji Institute of High Tech Education. I am very much delighted to present or introduce the speaker today, Mr. Kote Kiran. He is a senior engineering manager at Pega India Systems India Private Limited, Bengaluru. He has got overall 15 years of IT experience in building enterprise solutions in companies such as Carrier India Private Limited, Nest Technologies India Private Limited, IMO Communications Private Limited, and Pega Systems Worldwide India Limited. He is a skilled agile practitioner. He is a certified Scrum Master and also a certified ACFE Agilist. I would also like to welcome respected Principal Dr. B. Virappa sir, our Vice Principal Lata ma'am, and IQAC Coordinator Munwal Matt sir. Along with that, I would also like to our beloved students of second year BC, and I'll suggest them to gain maximum knowledge from this session. Now I kindly request Mr. Kiran to take over the rest of this session.
All right. Let me share my screen. Can you see my screen, everybody? I mean, can anybody confirm? Chetna, can you confirm? Can you see my screen? Chetna, can you hear me? Chetna, can you hear me? All right. I'll assume that you guys can see me. I'm starting off with this. All right. Good morning, everyone. Good morning, everyone. Thank you, Chetna, for that introduction. And myself, Kiran, I work as an engineering manager in one of the product-based companies in Bangalore. That's Pega Systems, which works for a BPM and CRM software. And I also work for different projects on working out their digital transformation journeys. I'm hoping that you guys can hear me. Okay, moving on. I'm just waiting for some confirmation that people can hear me. Chetna? All right, I'm starting off with the agenda today. Few of the brief points I would like to cover, like next 60 to 90 minutes on few concepts on the database management systems and very basic fundamentals on what is data information and how is this DBMS comes into the play and how is this evolution of databases right from when we started using this storing the data is concerned, right? And third topic will be ACID properties. Is basically properties of databases where we can maintain the consistency of the database and customer lifecycle. This is basically relates to the foundation stone for designing an enterprise system. And I'll also quickly show you on a quick demo on the how the relational database looks like in a real-time world by going through a simple example of one of the financial services application which I have been working on. And last 10 minutes or 5 minutes, we can basically keep the time for the Q&A. Okay, moving on. Just start off with a quick question. I'm not sure people, you guys can actually answer this in the chat window. Anybody can uh, differentiate between what is data and what is information? I'll just give a pause for 30 seconds and wait for the answers and move on. Anybody, what's your understanding of the data, definition of data and information? Okay, I see. I see. Okay. Any answers? Okay. Anybody, just take a guess on what's data and what is information. All right. So moving on. Few of the definitions which we'll talk about, and also I'm going to explain you about in the real time what is data, what is information, and what is database, right? So any unorganized information which we see in terms of like if you have a bunch of papers, right? I mean, laying on your cupboard. So it's basically a data. It has a lot of information, but yeah, I see some answers coming in raw fact and information is processed. Actually, absolutely right, right? So all this database information system and enterprise softwares are basically revolve around this data and the information, right? So as somebody rightly said, data is raw, unorganized facts that needs to be processed. Simple, seemingly random, and useless until it is organized. Let's say, take for example, in YouTube, you have 1 lakh videos, right? I mean, until and unless you search for a specific video which you wanted to see, there's no use of those videos, right? I mean, when you are doing that search, meaning what happens? Inside background, the processing is actually processed with your query, and it processes the 1 lakh videos which is available, and it picks out only the video which is basically searched by you. That's basically called as an information, right? So when data is processed, organized, structured, or presented in a given context so as to make useful, it is called as an information. That's absolutely right, right? So I just gave an example, very a clean example anybody can understand, right? YouTube, you search for a video of database systems. What happens in the background? It's actually runs an algorithm by picking up your search query, and then it filters you like 10 videos out of that 1 lakh videos. That is information. Data is processed, and it is actually it is given you a required information from the user. This is about the data and information, right? I mean, what about the database? What is actually a database, right? So we store this data in a particular place or maybe in a particular location. That's basically we are calling it as a database. It's all is an organized collection of data so that it can be easily accessed and managed. So how do we store this data? I mean, database is is a vast topic to be discussed, and I mean, how do we store this data? This data can be stored in a tables, flat files. We are going to see different mechanisms how it is actually evolved, right? So this is the basic fundamental concepts of before we dive into the evolution of the databases and what are the current trends and all this stuff. I'm hoping this is clear and how it is evolved, right? How is the database initially? Now we are all seeing the databases in the forms of only the tables, rows, and columns, right? I mean, that's one format. Another format is an encrypted format. But how it is evolved from the previous, we'll look up on some of the history of the databases, and then we'll discuss about the uh, current trends, right? The first database management system or first kind of a storage the information is stored is in the form of files, in the form of the flat files. It's files based. It is actually introduced in 1968. You look at this, the picture, right? So this is also looking like, this is a simple data file. You look at it: customer ID, customer name, contact name, and contact title. It is unorganized, but it is stored in a flat file so that the data can be stored. But what are the disadvantages of it? The disadvantage, the easy disadvantage which we can think of is searching the data. How do you search in a flat file, right? I mean, even though there are advantages of you can actually access this flat file in multiple ways, but the disadvantages are more. How do you search this data in a flat file? You have to write a program, complex program to filter out, like from 1,000 records you have wanted to display only the 10 records which is specific to a particular department. Then you have to write a complex program to filter it out, not just like you write a statement and you get it. That's the biggest disadvantage of file based databases. And next comes, I mean, hierarchical data model, right? So you look at this, there are example of hierarchical model, right? Company, you imagine a company or you're owning a company. It has users, machines, devices, and applications. And users, it has defined different users called marketing and personal users, right? So you see the object oriented, it's not really an object oriented, it's a hierarchical data model. The container and an object. What is the advantage of this? By this time we have the search mechanisms already available, right? The linear search and different algorithms. We can, the search is really faster, but organizing the data in this manner, and if you really wanted to change any data at the bottom of the tree or hierarchy, then it takes a lot of time for us. Next comes the network data model. This is basically dependencies are more. Stores, clerks. I mean, you see a retail store like a Reliance, take for example, it has the connections to all of its stores, right? I mean, transactions, items, and customers. This is basically a network. And the disadvantage of this network model is again the maintaining the consistency and retrieval of data is basically the biggest challenge in this network model. And there comes a relational database, right? I mean, 1970 is introduced and we are still using the relational database models. So I'm sure relational database model is everybody heard about this, and it's in the form of tables, right? I mean, we are rows and columns. You take, for example, the screenshot which I gave. Student is one table. We are storing the data, student data in a one table, and we are storing another table, the subject and the professor, and also the student's marks in a different table. So what do we see in this? We see a relation between these three tables, right? We don't, number one, we don't store the redundant data. We maintain the consistency, and we our updates and retrieval of data is much faster. So relational databases came into the picture. It is a very and from 1970 onwards, and it's well entertained by all the enterprise systems to move their existing data into the relational database models. Okay. So you see here, in the table we are talking about student ID is assume that is a primary key, and subject table, it's a subject ID is a primary key. We are using those two keys, and we are maintaining another table to store their information. This is called a relational database management system. Okay. Any questions, please feel free to put in the comments. I'll try to answer as and when I see. Otherwise, I'll answer at the end. Okay, thank you. What is the current trend, right? So what's going on? Are we still using the relational databases? Yes, we are still using the relational databases, but there are few disadvantages of relational databases. Is the relational database, as we discussed, right? We store the data in the form of tables and rows and tables, right? It occupies a lot of memory in your CPU. If you are storing a huge, like take for example, if you wanted to store an Amazon customer base, the trillions of billions of users of Amazon, right? So can we store the entire customer information on a single hard disk? No, it's not possible, right? So one of the uh, uh, disadvantage of the relational data. I don't say disadvantage, is basically one of the limitation. It needs more memory, right? And another one is, if you're storing the entire data in a particular system, and what if that system, unfortunately goes down, and your websites which is actually accessing that database is not able to access your systems at all, right? So that's availability and memory. These are a few limitations on the RDBMS, right? So what are the current trends which is going on? So as as we speak, I mean, as I speak, we are using both SQL and NoSQL, right? So SQL, we store the data in a relational database management system, and we need to retrieve the data. How do we retrieve the data? By using SQL, that is a structured query language. And now, in the recent, like say 6 7 years back, we are using another kind of a database called NoSQL database. What's the advantages of it? High scalability and availability. Availability in the sense, I mean, NoSQL database means we store the data in a different format, right? So I'm going to show you that in a little while. It has different forms, like uh, the graph model or the document model or the JSON format. You can retrieve by using just just by writing as Java language program. You can retrieve it. Cloud databases. Cloud database. The biggest advantage of the cloud database is, as an end user, I'm really not bothered about how do I manage my database, right? What all I do is, take for example of AWS. I take an AWS account, and I will just feed in my data into that account, and it stores the data into the backend. You are not responsible for maintaining the data or managing the data on a particular server. The cloud providers like AWS, Oracle, Google Cloud, these are all providing you a ready-made available database where you just use that as entering data and retrieving data. The maintenance of that particular databases is basically owned by the AWS, the companies like Amazon, Google, Microsoft, and all these companies have inbuilt their systems so that those systems are really reliable and scalable, and it is highly available. See, when I talk about the highly availability, I want you guys to understand there is a millions of transactions, or the financial transactions happens through the internet, per second, right? So what if the transactions fails in the middle by just not available, because the database is not available? So that's a huge loss to whomever is actually involved in the transaction. Let's say if you take about the money transaction, I am transferring a money from my account to another account, right? So there are three parties involved: my individual account, the bank of mine, and the receiver, and the receiver's bank. So it will be a loss if the transaction is failed at the middle. It will be a loss for the entire all the parties which is involved in that particular transaction. So availability of the database, availability of the software is highly important in this modern era. Okay, so some of the examples which we talk about the NoSQL database or MongoDB, these are highly, open sourced databases which is available, like something like an Cassandra, Big Data. Those are all the NoSQL databases, but the data is stored in a different format, not in a table format. It's actually stored in a graph database. It's actually stored in a document model. I'm sure you guys had heard about the hash maps, right? It has the key value pairs. So you store with the key, and the value will be stored. You actually retrieve by using those keys. So that's the cloud trends. We'll talk about it. I can show you some of them while I'm giving you the demo, right? The types of databases we talked about. A few of them we talked about. Centralized database, right? So I gave you an example of there is an millions of the customer data at one place, and uh, that will be accessed by different departments. Let's say, take an example, I'm owning a bank, right? I have my marketing department using the same data. I am using my uh, customer service department using the same data, and my uh, sales team is also using the same data. So if we centralize everything at one place, there are a lot of disadvantages. If it fails, the all the departments are basically will be on halt. So there are different mechanisms came into the picture. A distributed database, right? So we if you are actually developing a global a software which is globally used. When I say globally used, I have there is take an example of a Bank of America, which is basically in United States. Bank of America is also opening and branch in India. Quite possible, right? So uh, we will be using the same banking futures, but am I going to store my data, Indian customers' data into the US database? No, may not be a right thing to do. So what we will do is we will have a mechanism where the data is basically distributed across the locations if it is a global software, right? In the same way, you are sitting in India. I mean, I'm sitting in India. I'm accessing a YouTube or maybe a banking data which is actually located in a different country. Its performance will be really slow because it has to go all the way, right? So what we'll do, if some of you know about this cloud concepts, cloud has a different regions, right? So we'll distribute the data across multiple regions so that when I access the data which is available, I can actually quickly access it from my local region. That's the distributed database. And there's a lot of forms of distributed database. One thing I've explained, right? NoSQL database. NoSQL database meaning it's not only SQL. It's not that NoSQL at all. It's not only SQL database. We can actually store the data in the different formats: key maps, key value pairs, hash maps, and document related. Relational data we talked about. Cloud database we talked about, where there's a lot of maintenance overhead will go away from us. Hierarchical database we also talked about. An object oriented database is nothing but uh, everything is stored in the form of an object, right? So I'm sure you guys know about the Java. When you create a customer object, right? Customer has different attributes like name, address, and all these things. So everything is uh, binded in a particular Java object and stored that object in the database. That's object-oriented database model. Any questions so far? Okay. Uh, Differences between SQL versus NoSQL, right? So SQL is basically used for relational database. We all know about it. NoSQL database are categorized as non-relational and distributed database systems. We just talked about it. SQL database has predefined schema, right? So it has a structured language. You can actually use only that language to retrieve the data and also the schema definitions. It has a dynamic schema. So NoSQL, as I said, the data can be stored in tables, hash maps, and based on your storage mechanism, the schema can be completely different, right? SQL database is displayed. table-based database, and key value-based documents and graph databases. Vertically scalable and horizontally scalable. I'm going to talk about this later in a little while. Hierarchical data storage, and it's not bestly suited for hierarchical data storage, but hierarchical data storage is completely useful in the NoSQL language. The few examples on SQL versus NoSQL: MySQL, Oracle, SQLite, PostgreSQL, MS SQL, or the pure relational databases. MongoDB, Bigtable, Redis, Cassandra, HBase are the examples of NoSQL database. Okay, right. So, no, as I said, NoSQL queries are, even though we use the NoSQL database, we need a form of retrieving the data, right? So I'm just giving an example of NoSQL query. How do you write it? So this is purely a Java format. Collection. The users is a table here. Quality criteria: age greater than 18, name, one, address, and the limit. I'm just limiting to 5 records. Whoever is basically having this age limit greater than 18, I want to retrieve this. This is a NoSQL query. This is an SQL query. Projection: select ID, name, address from users table where you are writing a criteria, and you are just limiting it for 5. So this is where these are all like JSON format, lightweight format. There are different formats, right? We can use XML language format and JSON formats to retrieve the data from a NoSQL databases. So I just said in the previous slide, right? So vertical scaling and horizontal scaling. So before we go into this scaling concept, right? So why do we need to scale a system, right? What is scaling? Let's say, take for example, you started off your website, right? You have a database, you have a your website, like take for example of database.com, right? So you started off your website, and initially you have only 100 users, where your database is perfectly enough to serve those 100 users. So what happens? It actually became very popular, and your users went beyond like 100 to 10,000. And there is a difference, right? 100 users using a system and 10,000 users using a system. There's a difference in terms of the performance, in terms of the load, in terms of the server hitting, number of server hitting time. So all right, so it is designed to hold only 100 users. So what we need to do, either we need to increase our uh, database mechanisms so that it actually holds handle 10,000 users, right? So there are two ways you can do. One, you can actually add an existing, for an existing system, you can add more RAM, more CPU, more hard disk drive, so that people coming in, they can actually store the data. That's called as a vertical scaling. You will have only one system where you are increasing the resources of that particular system, so that basically it handles more number of users. That's a scalability, vertical scalability. When you talk about the horizontal system, what horizontal scaling, what we are doing is we are we are increasing the number of systems. We are distributing the data between different systems. I'm replicating the systems, and I will actually, if I have 10, in this vertical scaling, all the 10,000 users connecting to a particular, only a single database. In my horizontal scaling, what will happen is, if I get a 100 requests at a time, what will I do? I will basically uh, direct all these 100 requests into 6 different databases or 6 different application servers, which is available to me, so that the load will be balanced across all the systems and the response times will be much higher. which is actually useful, which can be used in terms of vertical scaling and horizontal scaling. It depends on the uh, a company's requirement. If there is a company can buy more systems, they'll go for horizontal scaling. If company is no, I don't have space to have more systems, I can only increase the current resource of the current system, I'll still go ahead and use the existing system and increase the more RAM and CPU. So this scalability comes into picture when the users are actually more. Still, you will be able to handle your system. Still, your system should be able to handle all the requests which is coming in, irrespective of the number. This is about the scalability, right? So we're talking about the SQL database and NoSQL database. So you see here, there's the third the picture which just came up, SQL database, the relational and analytical. NoSQL database, graph mechanism and document mechanism, and the key value pairs. These are pictorial representations of the NoSQL database, but again, different databases like MongoDB provides a different way, ArengoDB provides a different way to access the data. It uses the graph model or the document model. Hi, so this is about, we talked about evolution of databases, SQL, NoSQL, and different advantages and disadvantages of the both of them. Now, basic transaction management, right? This is a pretty uh, uh, important topic when we talk about the DBMS. Without this, we can't talk about the DBMS because these are the fundamental properties of a database management system. So before go for the properties of the transactions, right? So what is a transaction altogether? So transaction is a single unit of work, right? So some take for example of, right, you need to go and buy something on a grocery shop. That's it. You go to the grocery shop, you give money, and you take whatever is required for you and go back home, right? That's a complete transaction. A transaction is a single unit of work which accesses and possible the contents of a database, right? So transactions access data using read and write operations. uh, to maintain the consistency in the database before and after the transactions, certain properties are followed. That's called ACID properties: atomicity, consistency, isolation, and the durability. I'll explain each and every one, and we'll try to take an example of uh, a real-time example and try to explain all these properties so that we can actually correlate when any transaction happens in the database, right? So you look at the picture at the bottom left corner. A transaction starts, which is active. It is partially committed. When it is partially committed, it routes to the failed status, right? So you can see here, it is active, it is committed completely, and the transaction ends here. If it is failed, it aborts and it ends here. So there's a transaction life cycle. So a transaction, if we wanted to say a transaction is completed, that means it has to be fully completed, committed into the database as well. So let's try to talk about the atomicity, consistency, isolation, and durability. These are called asset properties of a database. Atomicity: entire transaction takes place at once or doesn't happen at all. Let's say, take for example, um, you are I'm sure you guys will be using the mobile applications or a banking application, right? So you open your banking application and there is a feasibility of updating your address, right? Address involves different parts. One is your house address, your phone, your contact details, and maybe your email ID, right? So my database is designed in such a way that these three stores in a different three different tables. It has to be, because if you wanted to store the entire contact information in a single table, it's always a high risk of the failures, right? So I have three tables. One is my address, another one is my phone number, another one is my email, right? How these three are related? By using my customer ID. I have my customer ID. Uh, there are two columns in this: customer ID address, customer ID phone number, customer ID email address, right? So I've opened my application and I updated all three. I changed my street name, I changed my phone number, I updated my uh, email ID. Correct. So I changed all these things on the UI and click submit. Right. What happens? Your business process layer basically processes it and takes the new values to the database and try to commit in a particular table. It's committed two tables and the third table is failed because maybe it has a corrupted data or your customer ID doesn't exist at all. Previously, you don't have email ID. Now you are trying to insert. These two are actually updates is insert, right? High chances of failure because you might not have handled that logic inside your business layer. So atomicity means if I am actually committing all these three tables, my entire transaction, it should commit all three tables so that my entire transaction is complete. Otherwise, it's not complete. So the two tables are updated. No, it actually rolls back to the previous state of the particular transaction. That's called atomicity. Comes back to the, I'll come back to the consistency at the end and isolation. Multiple transactions occur independently without any interference, right? So same e-commerce application if you take, right? So e-commerce application, multiple users doing a two persons are actually ordering the same item parallelly. Those two transactions should happen independently without any interference because two customers are different. Maybe the item is same, the customers are different, the seller is the same, nothing happens, right? So isolation means our database should be designed in such a way that those kind of transactions take place without any interference. Durability, system failures, right? I mean, this is basically when the system failures happens, we wanted to make sure the transactions are successful. That durability can be designed in such a way by using one of the component in the DBMS management system. So consistency, the last point, right? Why? Because I push this consistency. The last point is like, if we are able to manage this atomicity, isolation, and durability, your database is consistent, right? Database must be consistent. Even you entered the new customer details in database, the database must be consistent before and after the transaction. So these are the four basic fundamental uh, properties where we should keep it in on our mind when we are actually designing a database. Any database, you take it as a NoSQL database or an SQL database. The formats are different. How do we maintain these things in a NoSQL database and SQL database are maybe a little different, but we have to follow all these four as a basic fundamentals. Okay. Uh, any questions so far? I'm not seeing any questions here. Okay. Moving on. So I'm sure you guys must be learning the entity relationship diagrams. This is not clear, right? So let me open my, one second. Just trying to make this as big, the same diagram. All right, so you can see this is one of the real-time ER diagram for a specific application which I'm showing you in the real time. So this application is used by n number of customers across the globe. This is called as a knowledge management application from my company. So you can see this, right? So this is available as an open source in Pega website. So just we'll have a glance at this step at this ER diagram, and I'll try to explain the relationship between two different entities, and then we move on. So see, this is a system where it's basically a lot of articles stored in a particular system, and somebody wants to read the data or the articles from that particular database or a blog. You can actually think it is a blog, and it retrieves the data from that blog's system and it shows to the particular users, right? So just follow my cursor when I'm trying to explain this so that you try to understand these different languages, right? So knowledge management work. So when I request something from this system, it creates a case ID for me. And see, case ID gets created. It has a content language, it has a content master key, and it has a creation location, taxonomy info, and diagnostic ID. So content language is a different a table where it has a one-to-one relationship. Content language as an INSKey as a primary key here, and content key and language code. And again, language code is a foreign key here. I'm maintaining all my languages in a different table. You look at here, language data is a language INSKey is a primary key, language code, language name, and the description. So I'm actually requesting a content which is in a part. This is a content table, and this is in which language you are basically trying to retrieve it. So this is the one to many, and a single content can be published into multiple languages, right? So that's why you have a one to many rating here. And for that particular content, what you are receiving, what you are trying to retrieve, it has a ratings, right? So if you search something in an Amazon, you see a rating for every item, the users. If somebody has already read that and rated that particular content, I'm storing that in a different table altogether. This has a one to many. Aggregate rating is also, we can get the aggregate by doing some calculation. You can actually average it out to average. It has a 4 out of 5, like 3 out of 5, those kind of things. And you come down little and you see here the actual content here, right? So I have a content source, content type, publish time, when is this going to expire, review time, internal connect content flag, and show version. So these are all, you guys must be knowing it, right? So I have I'm publishing one content in my particular application. I'm going to uh, store the details at when I'm publishing and when I wanted to retire it. When I wanted to retire, meaning why do you want to read my like 1980 newspaper in my website? No, even though I publish that, I'll set it as a retire time of my Times of India or any other website will give me only for the data from last 10 years, not more than that. You can set an expiry time for that, and it has an one-to relationship with your basic table. So this is how a real-time ER diagram looks like. So this is an extension of the knowledge portal. We are extending that to a community portal where you have actually you can publish all these websites, you can publish all these contents in different portals. I have my own website. I also publish my links to a different channel or a website, so that basically when somebody clicks, it redirects to my website, right? So these are all again, this is just wanted to make sure I wanted to show this a real-time example, how the ER diagrams and the objects are actually have a one-to-many relationships and other stuff. Okay. Okay. Moving on. So I wanted to show you a banking application database walkthrough. Okay. Any questions? So before we go into the demo, any questions so far? Let's give 30 seconds for the questions. All right. Moving on. Probably I'm assuming that all are storing the questions to the Q&A session. So let's do that. All right. So this is one of the application where real-time application where I wanted to give you a demo on different how it looks like in the real time, so that you guys can correlate to what you are reading, right? So I just this is one of the application called financial services application where I just clicked on um, open the data model of that particular application, where how is this data is related and other things. So just give me a time. Okay, let it load. So what you're seeing is in one of the programming language we use internally called as an Pega system. This is you guys can go ahead and try this on the Pega website. There's a 30-day trial period where if you wanted to have a hands-on, you just still go ahead and try. This is called as an okay. All right. So I got I'll just take an example of I got an request to update to address for a particular customer. So how am I going to do that by using an application? I'm going to show that in the UI, and also we'll go back and look at the database table, how it is designed in such a way that there's no the normalization is completely followed, and how granular the database looks like in a real time systems. Okay, so I got a request to update the customer or the phone number of a customer called Robert, right? So I need to search the customer, right? So I'm going here and do a customer search. There's two different search types here. One is individual and organization, right? So individual is nothing but our retail, right? HDFC Bank has customers like us, and also HDFC Bank has customers uh, uh, like any organization. Take for example of Reliance people's as an organization has its account, right? So that's an organization address and organization entity and individual entry. So since we are dealing with Robert as an individual customer, I searched Ryan Roberts. He is my customer. I wanted to update his address, right? So I click on service customer. So once I click on the service customer, you see the complete information. Customer information is actually displayed for the representative. I'm the representative, which I wanted to update the address, right? So you see here his individual name, his employer, financial details, how much is net income, net equity, uh, a different risks associated to it, and his contact information. You see here his primary address is this primary contact, and his email address and the phone numbers here. You see here there are different tabs: accounts, household, relationship, documents, related parties, and goals. So that robots have a different may have different accounts, maybe a one savings account and one credit card account. Those details will be displayed here. I selected the account number as a card account, so it displays the cards which is related to that particular account, and also the transactions on that particular card, right? So what I am trying to emphasize here is, once we search a customer, we got lot of data in a one shot. But have we stored this data in a single table? No, not at all, right? So that's the point which I wanted to emphasize here. This accounts data may be coming from a different table. Household information is coming from a different table. Business relationships coming from a different table, and the documents, related parties. Roberts has actually has related parties in this area. So this all the information is coming from a single data source, that is a single database, but it's it's not from a single table, right? So that's how the database should be designed in a real-time systems. So this is called as a 360-degree view of a customer. So if you are, let's say, take for example, I'm sure you guys will do the projects in your last sem, right? So if you are having uh, hello, and can you guys hear me? Right. So if you're doing uh, projects in your semester, right? At the end of your semester, right? So when you're designing a library management system or any e-commerce solution, right? So keep this in mind in such a way that when any customer is open or any student in library management system open, we should display a 360-degree view of that particular customer in context of that in context of that particular software. Okay, so this is what it is. So again, as I said, this comes from different tables. We are going to see that in a little while. And what we wanted to see, okay, let's go ahead and check out. So I'm using a relational database management system. This is a Postgres SQL. As I said, relational database Postgres is one of the example. People use an Oracle, MS SQL, and these are all at the enterprise level softwares. There, this is a, a lot of investments can be made in Oracle and MS SQL. This is open source where you can use this. So okay, so I'm what we searched for. We searched for a particular customer, right? So we searched for a customer called Robert. So I go here, and if you guys can see my cursor, so see here, this is my table where all my customer details are entered. FSF underscore sample underscore customer. CUST is my customer. So let me write an query where I retrieve this data, right? So look here, the data you can see here. You see here the customer SIF number. There's a identification number, and the name is Rian Roberts. And what we have is tax ID and different details, employee status, web address, sticker, and all this. There's a lot of columns here, right? So we don't have something specific to his address or his maybe a contact details and other things. So we have his cash balance, we have his dividend interest, and all these things in a particular big table. And we don't want to put this address details also in this table, right? So if you see here, and I am taking this, I just wrote the queries in French so that we can actually see the outputs, right? So uh, all right, so see here, the Rian Robots, the customer ID is this, all threes and zero, right? So what I'm trying to do is from the customer address table, you see here, cust table, customer address, cust communications, or the three different tables where we maintain the customer information. So what I'm trying to do, I'm trying to get the address of this particular customer. How am I getting? This customer is having a identification number in my cust table, and I am taking that and I am searching in my customer address. See here, he has three different addresses for the same customer ID. He has three different addresses. Okay, in the same way, I'm going to get you. I wanted to get what is his communication methods. Communication in the sense how my bank should interact with him, right? So this is in a different table called sample underscore cust underscore comps. So I search here. See here, he has different records here, right? So he has a communication type as one of the thing, right? Email, Facebook, home, fax, and other work. So same customer ID, he has a different details here. Okay, so let's go ahead and so again, so before I go ahead and we talked about, so we saw there is something called as an households, right? So accounts, okay, accounts also we can see there is a different table, cust account x reference. That means I have a customer table, I have an account table, but what what accounts is being held by a customer, I hold it in a different table called xref table. That's basically a primary key and a foreign key, right? So I'm maintaining the data in a separate table so that I retrieve from that xref table directly rather than going to that table, getting the primary key, getting the foreign key, and again search it back into the UI part. So I have a customer account reference table where it has customer ID and account ID is stored in a particular table. So it retrieves the accounts data from this. In the same way, we have different households. You see here the sample household. Let me write in query. So you're seeing this Pega data, right? So Pega data is nothing but a schema. From this schema, I have multiple schemas in a same particular database. So I am actually retrieving it from a data Pega data schema, not from a other schema. So we have to specify the schemas. Otherwise, you don't recognize the tables where it is, right? So household. See here, there are different households in this particular table. So I can retrieve these households from this table, business relationship, documents, related parties. So everything comes from a different table. Cards and the transactions in the same way. You see here, customer CC account is nothing but a customer credit card account, and CC Tran is nothing but a credit card transactions. So I'll have the card details of a particular customer in this, and I will have a transactions in this particular table, CC Trans and CC account. Okay, so this is how the granular. So I talked about schemas, right? You see here, uh, Pega data and Pega rules. The classification of the schemas is also really important in terms of if there is a data or maybe a business rules which you have defined or wanted to store in a database, keep it in keep it separate in a different tables rather than the data tables. Data is uh, can be changed frequently, right? So I can update my phone number every 2 months, or I can update my email ID whenever I want. So we wanted to keep the data separate so that you can actually easily accessible and edited or updated can be done easily. Okay, so I see here there's a different naming conventions here, sample, ref, and all these things. So since we are providing the applications to your big customers, we provide this data as a sample data. In the real time, they don't use it. In the real time, they connect to their particular database systems, not to our database, right? So there's a connectors available which is on the system itself. Okay. Um, okay, let's go ahead and update some of the. Okay, edit communication preferences. See, you see here, edit communication preferences. We have social media details, Facebook, work, email. So you remember this, right? So we have actually comms table, communications difference table. You see here, you have email one, Facebook, home, other facts, and other work. See here, email, work, other facts, other work, and home. Email addresses is already here, rrroberts@gmail.com, facebook.com. This is all the dummy data. You just don't need to worry about it, right? So I'll try to update this, the home phone number, and see whether that works. Okay, I have updated that, and more communication preferences. See, you see here, and you go to the database, it should also get updated. So here we updated the home from 45 to 46. So this is how it is, right? So that the databases should be granular. The table should be granular in such a way that uh, it can be easily accessible, it can be easily readable by the particular users, right? So how it updated is a business end logic, in the business logic, which is basically written inside the program. So I'm not going to get there. I'm just trying to give you an example of uh, uh, how granular we can design the databases. All right. Um, Again, we can try any of the things here. So my whole emphasis here is your when you are actually defining the databases, you should a couple of points from this demo, right? So one is when you are designing any system or any software, you should get the customer 360-degree. Customers are the gods, right? You are developing a software for a retail e-commerce company. You should treat the customers as a god. So when and as also it should be easily available for the representative so that they can easily see the entire customer history at a particular glance. That's called a customer 360-degree view. And when we go to the database design, it should be as granular as possible. Uh, Take any attribute. You can actually take any attribute as a particular table and design in such a way and have the proper relationships between those between those tables. How many we are defining it? Okay. All right. Moving on. How much time I have? I have maybe another 15-20 minutes. Okay, so this is all about the databases in real time, which I wanted to cover. And the next topic is a smaller topic, which I wanted to cover is to give you guys a glance of how a an enterprise system looks like. Starts from UI and starts to the database, right? This may not help you in your exams preparation or something like that, but this give you an idea of if somebody wants to pursue your careers in a software industry. This actually helps you when you're hearing some seminars or something else. It gives you a quick thought about how a digital how an enterprise system looks like, right. So before I'm going there, right, so the customer life cycle. So take for example of any bank, right? So it has different uh, departments, right? So bank has to do a marketing to attract the customers, right? So you get an SMS on your mobile phones from your banks or from your telecom providers, like from Airtel or Reliance Jio or somebody else. So what are those messages are called? Those messages are called marketing messages, right? So you upgrade your data plan from this to this, you get this. That's a marketing strategy from a particular company which is providing. That's number one. Once you see the message, you may be tempted to upgrade your plan, right? That's basically then you call up your customer care center and okay, I got this message. What are the different details available on that, and can I go ahead and upgrade it? That's basically a second part. That means you are becoming a customer to that particular telecom company by onboarding yourself. Maybe a new customer, or maybe you're upgrading it to the particular plan to a plan A to a plan B. That's number one. Number three is once you upgraded your plan, you're supposed to get 3 GB of data free every day. But eventually, what happened? You're getting only 2 GB. So you're going to ask to whom you're going to ask. I'm going to call up my customer care center. That means my telecom industry should serve my customers. That's a customer service. And again, operations is basically all the backend operations of sending you the SMS, sending you the email, sending you the reminders, or for to onboard that particular um, customer onto the particular plan, they may need some separate documentation. Those documentations kinds of things actually can be handled by the operations department. So why I'm telling this customer lifecycle is any software, any enterprise software should be developed in such a way that you take care of all these points, right? So be it a bank, be it a telecom, be it is an e-commerce, any enterprise software should follow this customer life cycle. So for this to be operated, we need the softwares, right? We need a software. Different banks or different telecoms users, they use a different software for marketing, they use a different software for onboarding, they use a different software for customer service, they use a different software for operations. But when I say software, they're front end softwares, but the data is same, right? So I am the customer, Kiran is the customer for Reliance Jio. Reliance marketing team accessing my data is the same, and the onboarding team access my data will be the same, and the customer service also will access my data will be the same. The database remains the same. How many ever your software is connected to that particular database, right? This is an end-to-end customer journey. Um, Let me put this slide up. All right. So don't get confused by this diagram. So I'm going to explain you a little bits and pieces here. Uh, any software which we are developing, it has to be in a digital platform, and it is from a different channel. So I'm sure you guys should understand, if you are accessing an HDFC Bank app from your mobile, and if you're actually accessing an HDFC online banking application in your browser, just keep it in mind that the softwares are the same, right? This is called as channel. Mobile is a channel, web is a channel, mobile app is a channel, social is a channel. Social is nothing but your LinkedIn, Facebook, and Instagram, all these social channels, email and SMS. These are the different channels, right? Nowadays you get also a SMS, right? If you like this offer, press 1 and send, so that you can actually register for that particular plan. That's also called as an a channel based marketing, right? So, and these are all different channels, right? Any software which we are developing, that has to be supported by all these channels, and these are the upcoming channels. Engineering, chaos, gaming, and all these are upcoming channels which we still not started working on it, but the future is going to be the same. Is going to be, these channels also will get included. When it comes to an application, the exact software, right? So experience layer, digital optimization, digital content, everything has to be digital, multilingual, right? So um, the same application I'm using in India and the China, or maybe in the Korea, it has to be translated easily from one language to another language. The software which we are developing, we don't develop in multiple languages. We develop only for one English language, and we translate that language into a particular language where we want it to, right? So that's multilingual. And dynamic content is nothing but a storage. Digital consumers and stakeholders, right? Prospecting and marketing, we talked about. This is a complete customer life cycle. Marketing is a different software, CRM is a different software, ERP is a different software, and all these things, integration layers. So this is where I talked about, right? That even though you have a different softwares, but those are all integrated to a single database sourcing system. Those integrations layers also we need to define in such a way that integrations are seamless. Seamless, when I say seamless, it should be used easily. We should not spend like hours and hours or together to just do integration. We just you guys should have heard about plug and play, right? So just plug and start working on it. Enablers and digital data infrastructure, you can use the cloud, you can use APIs, you can use the payment service and all these things. So this is how a external integrations also talk about public or partner cloud, social cloud, external apps. Big topic to be discussed. This is a typical a big an enterprise system looks like in a real time. This is how the enterprise systems looks like. There are 5 points which actually I've listed here to be to register in your mind. Omni-channel platform. Omni-channel platform meaning, as I said, the software must be accessed on all digital channels which is available. Simplified experience across screens. mobile screen and your uh, net banking screen on the browser should be the same. It should be as simple as such. The user should not click 10 times to reach to complete his transaction. You should provide a different controls at different places so that the user can have a simplified user experience. Latest technologies seamlessly integrated. I talked about it. So you developed a software using uh, Oracle, right? Just take for example of an Oracle database, right? So Oracle 8, and after an year, Oracle 10 has released with the latest technologies. I wanted to move my entire application to Oracle 10. It should be it should be seamless. It should be easily lift and shift into the Oracle database, Oracle 10 database. Enterprise level security, scalability we talked about, reliability we talked about. Security is a topmost thing. In some of the applications where I have seen, there might be one layer called a security layer where it provides authorization, it provides authentication, it provides an LDAP connections. It is a security is a completely different layers. It uses different protocols to connect to, at least you enter into that particular system, right? So banking systems are like that. Open architecture with a thriving API ecosystem. This is a really important thing, right? So uh, you guys must be developing, have an experience of developing a mobile app. Now that Android is a open source platform where you can actually develop your own app and publish on the Google Play Store, right? So how does it looks like? What is an API? It's called as an application programming interface, right? So you developed a, let's say take example, you guys must be using your Google Pay, Phone Pay, and all these things, right? So that actually works on a platform called Beam, which is introduced by Government of India, right? So if you see, the Paytm UI is different, your Phone Pay UI is different, right? But you, from these two apps, you are actually connecting to your own bank account, right? So that means these two have two will two have two different will not have two different APIs to connect to your bank. It's provided by the platform called Beam platform. It provides an API. It provides an application program. Okay, Kiran is having this account. If you wanted to use, any app can use this platform to access his information. Bank will not allow you to 10 different ways to access your account, right? So that's a particular thing. So what Beam has done, Beam is basically in it designed an API. Okay, if you wanted to access a bank account of a particular person, use this. You just send me the customer ID or the bank account number, I'll give you the details. That's it. Your Paytm doesn't know how much the background processing happens in the Beam UPI. Now how do we segregate that, how do we hide those data into the UIs, right? So that's called an API. If you're developing one functionality, make sure you develop that as an API so that it can be externalized to any of the particular customers. Okay. All right, so I think I did it, maximize the screen. So I think you guys can see this, and this is about the enterprise system. So the last two slides are basically I've given it for your food for thought, because you guys are going to be in a software industry for long, and this is the way the software systems looks like, not the way. If you take this as in a base when you are developing any small system like a library management system, or an e-commerce application, or a hospital management system, think about all these things and develop it so that when you come into the real world, you will be much faster in learning the things, and you can adopt more quickly into the digital architecture software systems. Okay. All right, I think I'm done. I have another 13 minutes for Q&A. Any questions, if you guys can ask, I can actually, I'm just watching out here for the questions. Any questions here? Makes sense. I mean, you guys understood at least some part of what's in terms of the uh, databases and how it is evolved in the past, and how the modern enterprise systems looks like.
Okay, I request the students to, if you have any doubts, you can ask the questions. Post your question through the chat box. I request the students to, if you have any doubts, you can ask the questions. Post your question through the chat box.
All right, so I'll just keep watching for the questions, but I just wanted to add few more points in terms of real-time
All right,
software
so
systems.
I'll just keep watching for the questions, but I just wanted to add a few more points in terms of
I'm hearing the echo.
real-time software.
Okay. Yeah, I mean, we talked about this enterprise software building systems, right? So it's always good to keep those things in the mind in terms of when you're developing a software. The security is one of the thing, and managing the workload or managing the load on the particular systems is really important. And also uh, scalability we talked about, right? So think in terms of the digital. Digital is what the future is going to be, and when if you start doing these things in your college projects, I think it will be really useful for you guys to those thoughts get into the real world and take those knowledge and apply it in the real world, right? So this is what it is in terms of the digital transformation looks like. So authorization, authentication, securities are a different big topics. A few of the things which you can focus on the technologies like cloud technologies and microservices and uh, API building, mobile application development. These are the different topics where you can focus on in learning it. So, addition to all these things, of course, your basics are really important. You should learn your data structures properly, and you should remember those data structures throughout your career if you are in a software industry, right? So, data structures, lean search mechanisms, all these things are basically highly important where you should really focus on when you are developing a application. Okay, I don't see any questions. Chetna, you there? You're not audible, ma'am.
So I'm Swati here, another faculty of the Bapuji Institute of High Tech
Okay.
Education. Okay. Are you done with your
Yeah,
presentation, Kiran?
I'm done. I'm just waiting for at least one question to be answered, but it looks like no question. So
Okay. Okay. Shall I move for the vote of thanks?
Sure. Before that, actually, so I would like to thank the principal, sir, Dr. B. Veerappa, sir, and the coordinator, Munavalli Mutt, and Cherna ma'am for giving me this excellent opportunity to talk to the students, and last but not the least, all the students who have joined in this webinar. Thanks for patience, and I'm reachable through Chetna ma'am. I'll share my details with Chetna ma'am, my email ID. If you guys have any questions, would like to have any shorter discussions, I'm open for that. Once again, thank you for the opportunity, and wish you good luck for everyone.
Thank you, Kiran. Thank you so much. Now, I would like to express my heartfelt gratitude to the speaker, Mr. Kiran, for accepting our invitation in spite of his busy schedule and for sharing his valuable knowledge with our students. Thanks, Kiran, for joining us.
Thank you very much, Swati ma'am, and thanks everyone.
Okay, and I also would like to thank the Dr. B. Veerappa sir, Principal, Bapuji Institute of High Tech Education, and also I would like to thank Manwali Mutt sir for coordinator of this virtual talk, and I would like to thank all the students who have joined to this session. Again, thanks everyone for joining this session. Thank you so much.
Thank you. Bye bye.
Bye bye.